In this exercise, we will create a Python program to compute the price of an item after a 20% discount. This exercise will cover the following topics: function definition, variables, arithmetic operations, data types, formatted string literals, printing output, and function call. So let's start this exercise by discussing how functions in Python work. So a function in programming is a block of code that performs a specific task and can be called with a set of parameters. In Python, a function is defined using the def keyword, followed by the function name and parentheses. In this case, for this exercise, we will name it calculate discount. So here we have the def keyword, the function name, the parentheses, and inside the parentheses you can specify parameters, which are variables that the function can accept as input. And the column here indicates the beginning of the function's body, which is the intended block of code that follows. Keep in mind, in Python, indentation and colons are used to define code blocks, whereas in many other programming languages like Java or C, JavaScript, curly braces are used. This is how indentation works in Python. It just defines the structure and flow of the code. As you see here, generally the first level of indentation is used for blocks directly under the main code. Typically 4 spaces are used for this level. So if the begin of if and print belong to the first level of indentation, the second level are used for blocks nested within another intended block, which in this case is a print, but it can be an if statement inside a for loop. And this second level is achieved by adding another 4 spaces or 1 tab, making it a total of 8 spaces from the original starting point from the here def. So as you see, each level of indentation helps visually represent the structure and flow of the code, making it easier to read and understand the hierarchy and scope of different blocks. So we will name the parameter this function will take as price. This function will take this parameter to allow it to calculate the discount for any given item's cost. And by using a parameter, the function can be reused for different prices. And when analyzing the price parameter in this function, it opens an opportunity to discuss how variables work in Python. Variables are fundamental in programming as they store data values that can be used and manipulated throughout the code. The price parameter is a variable, which means it stores a data value that can be used and manipulated within the function. And how variables work in Python? A variable is created by assigning a value to a name using the assignment operator. Let's write quickly an example. So, as we said, a variable is created by assigning a value to a name. Variables in Python are dynamically typed, meaning you don't need to declare their type explicitly. Python infers it from the assigned value. So in Python you simply use the variable without declaring its type, while for example in Java you must declare the variable type. For example in this case in Java it would be like int or string. In Python you don't need to do that. And understanding this topic leads us to explore data types, as each variable holds a specific type of data, such as integers, floats, or strings. In Python there are three basic data types. So data types determine how the stored data can be manipulated and what operation can be performed on it. Integers represent whole numbers, both positive and negative. We can add here floating. Which are numbers with a decimal point. In this case it would be, for example, this is strings represent sequence of characters enclosed in a single or double quotes, as you see here. And booleans represent true values, either true or false. So the concepts of variable and data type are interrelated because a variable's type is defined by the value it holds. When you assign a value to a variable, for example here, 25 to age, we are assigning 25 to age, Python dynamically determines the type of the variable based on the value it holds. And this relationship is very important because the type indicates what operation can be performed on the variable and how it is stored in memory. So it means you cannot perform any type of operation on any variable regardless of its type. The operations you can perform depend on the variable's data type. For example, arithmetic operation can be performed on integers and floats, while string operations are specific to text data. So with integers and floats you can perform arithmetic operations. With strings you can perform string concatenation and repetition. And with booleans you can perform logical operations like AND, OR, and NOT. And mixing types in incompatible ways will result in an error. I cannot do, for example, Peter minus 5. This will result in an error. Therefore, it's important to clearly understand these initial concepts to be able to program without making mistakes. As I said, these are basic types that are essential for most programming tasks. However, Python also offers other data types such as lists, tuples, dictionaries, which we will explore later. So having clarified this, let's return to the exercise. Sorry, here not just float and floating point number. We can name them both ways. So once in the body of our function, our first line will be about calculating the 20% discount on the original price. So it's the price we enter as a parameter, and we will calculate the 20% discount. So price is the original cost of the item. 0.2 represents 20% as a decimal, and this multiplication computes 20% of the original price. And discount stores the calculated discount amount. Next, we will calculate the final price of an item after applying the discount. So price, again, is the value we enter as input, and discount is the amount to be subtracted from the original price that we calculate earlier as 20% of the price. So this performs the subtraction to determine the reduced price, and discounted price stores the resulting value, which is the price of the item after the discount has been applied. So as you see in this part of the exercise, the price and discount variables hold numerical values representing the original item cost and the calculated discount. Both belong to float data type, which allows for decimal calculation. The variable discounted price is also a float, storing the result of subtracting the discount from the original price. So as you see, this shows how variables and data types are used to perform and store arithmetic operations. So now that we have done the calculation, it's time to print the results. And for that, there is a function that is used to output text or other data to the console. It is a native function that takes a native Python function that takes one or more arguments and displays them as a string. By just invoking the keyword print, we are already able to print whatever we want in Python. Keep in mind, if you want to print a text or a string, it should be always enclosed in quotes. If I want to print, for example, "Hi, I am programming," for example, that should be always with quotes, simple or double quotes, like in this case. And with numbers, you don't have to enclose numbers in quotes because they would be treated as strings, so that's an error. So strings are always without quotes, just like this. Let's see this quickly in the console. New terminal. Let's comment this just for a moment. We save it, and we have the number. if you want to concatenate a number with a string, we just have to do it enclose in quotes only the text that we want to print, separated with commas, and let's display it. Hi, I'm 87 years old. However, in this case of these functions, we have variables, so we should be able to display them in the console through this print function. If, for example, suppose you want to print the original price, the price will pass as a parameter. So for that we will have to use formatted string literals, which has these syntaxes. So here we will print the original price and the discounted price. With this F syntax in Python, we can display formatted string literals. A formatted string literal is a way to embed expressions within string literals using curly braces. A formatted string literal is a way to embed expressions within strings, and this is a formatted string literal. It's a way to embed expressions within string literals using curly braces. So inside braces you can place variables or expressions that will be evaluated and included in the string. An important aspect of formatted string literals is that it makes strings dynamic by allowing variables or expressions to be embedded directly within the string. And this means the content of the string can change based on the values of the variables or the results of the expressions at runtime. And we achieve this with this syntax, which is F at first and then $, curly braces, and the variable we want to embed. So let's see this in action by printing the result of our function. First we will open the terminal, and before printing our result, let's focus on the end of the function, which is the return statement, which is responsible of sending a value back to the caller, which allows the function to provide output that can be used for display. And the value we are interested to display is discounted price. So we will return discounted price. And this allows the function to pass back a result to the caller, which can then be used for displaying in the console, as we previously said. So now let's print our result. Save it and let's run it. So these two lines are printed by the print statements within the function when we call the function and we pass 100 as a parameter. Good, so these are the topics we will explore in this exercise. We will review the creation of a function in Python with all its details, then lists and dictionaries, which are advanced data types in Python. Remember, in the last exercise we covered the basic data types, which are integers, strings, and booleans, or integers, floating point numbers, strings, and booleans. And advanced data types focus on ways to manage collections and complex data structure. For loop, which is used to iterate over a sequence like this one, list of dictionaries, and allows us to execute a block of code repeatedly for each item in the sequence. And then a conditional if statement, which is used to execute a block of code only if a specified condition is true. Good, so here we have to create a function that looks through a list of dictionaries, each representing a user. And the function should find and return the dictionary where the first name key has the value brown. So it should return this dictionary. So in Python, this user variable is a list of dictionaries in Python. Each dictionary represents a user and contains 3 key value pairs: first name, last name, and age. So this is a list of dictionaries. A list is like an array in JavaScript, and dictionaries are like objects. Dictionaries in Python are similar to objects in JavaScript. Both are used to store key value pairs. And as we said previously, in Python, unlike JavaScript and many other languages, you don't need to create keywords in order to declare a variable. You simply assign a value to a variable name directly, and in this case, users is a variable that holds a list of dictionaries. But let's quickly go over what lists and dictionaries are in Python. A list is a data structure that allows you to store an ordered collection of items. These items can be of any data type, including integers, strings, floats, and even other lists. Let's quickly create a list. So as you see, lists are defined by enclosing a comma-separated sequence of elements within a square brackets. It is heterogeneous, meaning that can contain items of different data types. As you see, here is a number, string, boolean, float. It is ordered, which means it maintains the order of items. Each item has a specific position index starting from 0. And it's mutable, meaning you can change the items in a list after it has been created. This includes adding, removing, and modifying items. And to perform those operations, lists provide different methods. Python lists. So Python lists come with many native methods that allow you to manipulate and interact with the list in different ways. Here I show you only three, but there are many. But this one, for example, append, add an item to the end of the list. This 6 is the item we pass as argument, and this will be added to the end of the list. Insert, it inserts an item at a given position. So the position is 1, and as every list starts from 0, the 1 position is the second. It would be I'm adding number 9 to the second position. So this is the output. And the possibility to use this method on lists corresponds to the characteristic that lists are mutable, which means that lists can be changed after they have been created. Alright, so now let's move on to quickly explain dictionaries. So a dictionary in Python is another data structure that stores data in key value pairs. This means each value is associated with a unique key. As you see, for example, here, the key is first name and the value is John. Key is last name, the value is Doe. Key is age, the value 30. So a key value pair consists of two elements, a key and a value. The key is used to identify the item, and the value is the data associated with that key. You can create a dictionary using curly braces, as we implement here, with key value pairs separated by colons. And the main characteristic of dictionaries is that first they are unordered. This means that the items, the key value pairs, are not stored in any particular order, and the order of the elements can change when the dictionary is modified. So that's a difference between lists and dictionaries, because lists maintain the order of elements. The elements in a list are stored in a specific order, whereas dictionaries don't maintain a specific order of elements. Keys should be immutable and values can be mutable. And this ensures the integrity of the dictionary, as changing a key could mess up the structure used for key value mapping. For modifying or adding or deleting the data stored in a dictionary, there are methods like in lists, but in dictionary, using bracket notation to add or update a key value pair is much more common syntax feature than using methods. For example, let's see how to manipulate the data of a dictionary. So in the first case, I'm adding a new attribute to this dictionary. It would look like this. So in this case, I'm adding a new attribute, profession engineer. And in the second case, I would be modifying the last name to Brown. So we are not calling a method in this case, but rather using a syntax feature to add or update a key value pair in a dictionary, which is much more common when it comes to dictionary to do it like this than using methods like we do in lists. So now let's write the function that will search for that specific dictionary. So remember, when declare a function, def is the keyword used to define a function. Find user is the name of the function, which should be a descriptive name indicating what we are going to do, and these ones are the parameters, which means that when we finish this function, then in order to see this function in action, we will have to call it, and when we call it, we will pass two arguments, users and first name. The first argument will be the list, and the second the name that we are looking for. And now to process all the elements of this list, we have to iterate over all the elements of this list in order to handle and manipulate the data in order to meet the requirements of the exercise. And for that we will implement a for loop. So as simple as that, we have a for loop defined in Python. It's much more flexible and easy to use compared to other languages. You see, unlike languages like C or Java, Python does not use parentheses or braces to define the scope of the loop body. Instead, it uses indentation, which is represented using space or tabs at the beginning of lines of code. In addition to that, in Python, the for loop directly iterates over elements of an iterable without needing an explicit index or counter variable. So for is the keyword used in Python to start a loop. Then user is a variable name that represents each individual element or item within the user's list during each iteration of the loop. You can name this variable anything you like. It doesn't have to be user if you don't want to, but it's just common to use a singular form of the list name just for clarity. In is another keyword in Python that is used to specify what the loop is iterating over. And users is the name of the list over which the loop iterates. Alright, so as we said, during each iteration, user represents one dictionary from the users list. So inside this loop, this for loop, we need to include a conditional statement that will be nested inside the for loop. And the function of this conditional is to check if the value associated with the key first name in the current user dictionary that the for loop is evaluating is equal to the first name parameter that we pass to the function. So let's see how this if conditional looks like. So if is the keyword used in Python to start a conditional statement. User, as we said, is the variable that represents each dictionary as we iterate through it. And this part access the value associated with the key first name in the current dictionary that we are iterating. This is a comparison operator in Python that checks if the value on the left is equal to the value on the right. This is effectively a value that we are going to pass to the function when we call it, because remember we set this value in the parameter that represents the first name that we are searching for in the users list. Overall, this line is checking if the value stored in the first name key of the current user dictionary is equal to the first name that we are looking for. So if the condition is true, which means that the function has found a user whose first name matches the specified first name that we introduced when we call the function, in that case we return user. Otherwise, we return known. So in this case, the function immediately exits the function and returns the entire user dictionary back to the caller. This ends the function execution at this point, in case the function finds the user we are looking for. Otherwise, we return known. And by returning known, it means no matching user is found. So the function provides a result to the caller that the search was unsuccessful. And as you see, unlike some other programming languages, Python does not require an else clause after an if statement. In Python, you can use if statements alone to handle cases where a condition is true, and then proceed with the rest of the code without needing to state what happens when the condition is false. Generally, in Python, the use of else with if statements is just for specific cases, but normally this language encourages writing code in a way that makes the flow clear and readable without needing explicit else clause, which can reduce unnecessary nesting and make the code more straightforward to follow. Good, so now let's print the result of our function. and the result is known. Why is known? Um, or because I'm passing a last name, I just let's try with Jane. Save it and still known. Oh, the variable is enclosed in quotes, which means I'm comparing the user I'm iterating with the exact string, and that's not right, and here should also match. I should compare it with a variable and not with the exact string I'm iterating here. But no problem, errors are always good because we learn from them. So now let's save it and run it. And here's another mistake. Good that you see and learn from it. Here we have an issue with the indentation of the return known, which is placed inside the for loop. And to correct this, you need to ensure that the return known is outside the for loop, so that it's only executed if the loop completes without finding a match. Therefore, we should place it at the same level of indentation as the for loop. Indentation plays a very important role because it replaces the traditional use of curly braces, which has to do with Python's philosophy that gives so much importance to simplicity and readability by avoiding curly braces, parentheses, and so on. So it's not just a matter of style, but a core aspect of the language syntax and readability. So remember, you should always follow these indentation rules. So now let's save, and now we get the right result. We passed as a parameter the list of dictionaries and the first name we were looking for, and we get the dictionary that match this first name. Alright, so in this exercise we should write a function that prints all even numbers from 1 up to a given number, so to the number that we that. Alright, so in this exercise we should write a function that prints all even numbers from 1 up. Alright, so in this function we should Alright, so in this exercise we should write a function that prints all even numbers from 1 up to a given number n. So it means the number that we pass to the function as a parameter. So let's declare the function. Now let's declare a variable that acts as a counter. It will be used to iterate through numbers from 1 to n. So I is the variable, equal is the assignment operator. It assigns the value on its right to the variable on its left, and 1 is the initial value assigned to I. So that means that the iteration will start from 1. Then we will set a while loop that will repeatedly check each number from 1 up to n. So n is the number that we will pass as a parameter. And by incrementing the counter, this counter, in each iteration, the loop ensures that all numbers in the specified range are evaluated. And this will allow the function to print all even numbers from 1 to n. That is a number that we will pass as a parameter when we call or invoke the function when we finish the exercise. So this while loop will continue to execute as long as the given condition is true. And what's the condition? This one is the condition, which means that the loop will continue to run as long as I is less than or equal to n. This means the loop will iterate through numbers starting from 1 up to n. So now we need to check whether each number in the loop is even. So inside the while loop we will have to set an if statement that calculates the remainder when I is divided by 2. So if the remainder is 0, it means that I is an even number. Therefore the code will be like this. You see, it throws an error if I use just one equal sign. You see, if I use just one equal sign, it throws an error because in Python I must use two equal signs for comparison. So to compare whether two values are equal, we should use double equal sign and just one equal sign here in this case, just to assign a value to a variable. So we can name this one equality operator and this one assignment operator. So this distinction is very important when it comes to Python. So as we said, this condition calculates the remainder when I is divided by 2. So if the remainder is 0, means that I is an even number. And what should happen if we find an even number? Then we should print it. We should print I. We should print the current value I to the console, which is executed only if I is even. So this condition checks if I is even. If I satisfies this condition, the corresponding print statement executes. And what happens if it's odd? So in that case, the print statement does not execute because the condition evaluates to false. However, in both cases, the I variable, whether it's even or odd, should continue to increment by 1 after each iteration of the loop, up to the number we pass as a parameter in n. So how should we increment this variable? Just by incrementing the variable by 1 with this symbol. So this increases the value of I by 1 in each iteration of the loop. And this is a shorthand notation for it is just a shorthand way to update the value of I without having to write this long, not so long, but anyway, this notation is very common in not only in Python, in many other languages. And without this line, this variable would remain unchanged within the loop, causing it to repeat indefinitely, and this would prevent the function from completing its task of printing even number up to n. Therefore, the incrementation of I ensures that the loop iterates through each number in the range and progresses towards the termination condition. So now let's print the result of this function. And here, as we are printing operation internally, we don't need to add an additional print statement here. So just by calling the function is enough. Say 20. Let's save it. And here we have all the even numbers up to 20. So we are invoking just by invoking the function, it prints the result of the function that internally handles printing even number internally. Good, so in this exercise we should create a function that takes a tuple as input, and the goal of this function is to determine whether all elements within a tuple are identical. Let's define a tuple. For example, my tuple is equal to so for this case the function should return false because they are all different. All the elements of the tuple are different. If they are all equal, for example in this case, it should return true. But let's quickly review what a tuple is. In this exercise we should create a function that takes a tuple as input, and the goal of this function is to determine whether all elements within the tuple are identical. Let's define a tuple. So in this case the function should return false because all the elements are different, and in this case it should return true. But first let's quickly review what tuples are. A tuple in Python is a collection type that, like a list, is used to store multiple items in a single variable, as we see here. One of the key aspects of tuples is the immutability, which means that once a tuple is created, its elements cannot be changed, added, or removed, which is not the case in lists, where they are mutable, meaning their elements can be changed and items can be added or removed. Regarding the syntax, tuples are defined using parentheses, unlike lists, which they are defined using square brackets, like this one. This is a list. In both cases, items are separated by comma. But let's return to the tuple. So a tuple typically is used when you have a collection of items that should not change throughout the program. for example, days of the week, or coordinates. Let's see this quickly in the code. Let's try to modify this tuple. In this example, I will try to change the first element of the tuple to 4. So it throws an error. Tuple object does not support item assignment. In case it would be a list, let's run this code. And in this case, this is allowed because lists are mutable. So it let me replace the number 1 for the number 4. With tuples, we cannot do that because they are immutable. Alright, so after this brief overview of what tuples are, let's move on to the exercise. So now let's define the function for this exercise. So for this function, first we need to handle the cases where the tuple is either empty or has only one element, because in these cases it is considered that all elements in the tuples are the same by definition. Therefore, in that case, the function can immediately return true. So let's handle that case. Good, so here we are checking the length of the tuple. Len tuple returns the number of elements in the tuple, and less than or equal to is the condition that checks if the length of the tuple is less than or equal to 1. Len is very common in Python. It's a function that is used to determine the number of items in an object. Remember, in Python, everything is an object, which includes tuples, lists, strings, dictionary sets. So the len function is designed to work with any object that defines a length. It's just the same as length in JavaScript. For example, this line in JavaScript would be like so in JavaScript this condition would check if the length of the array, because tuples does not exist in JavaScript, so it would be an array. It checks if the length of the array is less than or equal to 1, and it returns true if the array is empty or has only one element. So let's return true here. And here, as you note, it throws me an error because it's important to use true with an uppercase T. So when it comes to booleans, literals, in Python, it's important to use true and false with uppercase. Using them with lowercase letters will result in a name error, because Python does not recognize them as valid boolean literals. That's why Python is case sensitive, so true and false must be written exactly as shown. And now, in order to meet the requirements of this exercise, we will need to store the first element of the tuple into a separate variable. So in the context of this function that checks if all elements in a tuple are the same, this line is used to obtain the reference element, the first element, against which all other elements in the tuple will be compared. So this line stores the first element of the tuple, and then we will need to write a loop that compares each element in the tuple to first item. So in this for loop, we compare each element in the tuple to first item, and if any element is different, the function will return false. And if no elements are different, the function returns true, indicating that all elements in the tuple are the same. Let's print our result. So false, the first one, because the elements are all different from each other. Here they are all equal, and so the first one false because they are all different. The second one is true, they are all equal. For an empty tuple, the function returns true because there are no elements to compare. And let's try it with a single element. Throws me an error because no comma, I should write a comma. And it returns true because there is only one element, so logically all elements are the same. So this function is a good alternative, but there is another one that is less verbose and more Pythonic. In this exercise, we will create a function that will check for common elements between two sets. If there are common elements, that function will return those elements. If there aren't any, it will return an empty set. And in this exercise, we will tackle these topics. Well, function definition that we already explained in details. Sets, which are another type of advanced data that we still need to discuss. Remember that the advanced data types include lists, tuples, set in this case, loops and conditional statements, and adding elements to sets. Sets in Python are another collection type that represents another collection of unique elements. In terms of mutability, sets are mutable, meaning you can add or remove elements after the set is created. So they are mutable like lists, but not like tuples, which are immutable. And another key aspect of sets is the uniqueness, which means that sets don't allow duplicate elements, while lists and tuples can contain duplicate values. In terms of order, lists and tuples maintain the order of elements, while sets don't guarantee any type of order. So when it would be useful to use sets? Well, especially when you need to work with unique elements and perform efficient membership testing, or when you need to perform set operation like union, intersection, or difference. So those are the cases where sets would be useful for us. Every type of collection has its utility. Sets when you need to work with unique elements, tuples when you want to ensure that the collection data remains constant, immutable, so that you can work with fixed data, or lists when you have a collection of items that need to be modified or where the order of elements matters. And now let's see what the basic syntax of the set is like: so here we are creating an empty set. When creating an empty set, it's important to use the set function, because sets and dictionaries both use curly braces, but they are used differently when creating empty collections. So let's run this print, and here we have an empty set. And in this way we avoid confusion with an empty dictionary which is created using curly braces. So using set makes it clear that you are creating a set and not a dictionary. So sets and dictionaries have similar syntax, especially when they contain elements, but they work different when they are empty. So understanding this difference helps you avoid confusion. Now let's see how sets work when they contain elements. So as you see, we can add to a set different kind of data types: integers, strings, and this is a list. And if I run this set, we have an error. So this error means set cannot include collections, but it can include floats, for example. Oops. Let's run it. So take a look at this output. The output of a set in Python can vary in order because sets are unordered collections. When you print a set, the elements may appear in any order. And refreshing what we saw about the differences between dictionaries and sets, see that both use curly braces. Both are separated by commas, but in dictionaries there are key value pairs separated by commas. Here we have just single elements. So with a better understanding of what sets are, let's continue with the exercise. First, let's define the function with its parameters. So first we initialize an empty set. Common elements is a variable that is initialized to an empty set. And this empty set will be used to store elements that are common to both sets, set 1 and set 2. Now we will define a for loop that iterates over each element in set 1. So element is the variable that will take the value of each item in set 1, one at a time as we are iterating. And the line of this if statement checks if the current element from set 1 is also present in set 2. And if the condition evaluates to true, it means that the element exists in set 2, and false otherwise. And if the condition is true, the block of code will execute in this adding the specific item to our empty set. And then we return that empty set with now including all the elements that are common. Let's print the result. Let's run it. And the result is 3 and 4. An alternative approach to resolve this exercise is, instead of manually checking each element in one set to see if it exists in another set, you can use a built-in set method to find common elements more efficiently. This approach is much more shorter, and this method provides a way to find and return the elements that are common to both sets. So instead of looping through each element and checking for its presence in both sets, this intersection method directly computes the set of common elements. Besides that, it is much more shorter and easier to read, making it clear that the task is to find common elements between two sets. Let's save it and I'll run this program again, and the result is the same one.